Dear students, today we are discussing about conditional probability. Let A and B any two events. The probability of an event A given that B has already occurred is known as conditional probability of A given B, and it is denoted by probability of A given B, and it is defined as probability of A given B is equal to probability of A intersection B divided by probability of B. So I will uh, draw a picture so that you can understand the concept in detail. Suppose this is the sample space and this represent event B, and this represent event A. So this is actually the sample space S. This is S sample space. This is B, and this is A. So we are actually trying to find out the probability of A given A in B, A given B. That is, if B has already happened, then what is the probability of happening A? So given B, what is the probability of A? So that is we are actually trying to find out. Okay. So that is denoted as like this, and you can write the probability of A given B as probability of A intersection B divided by probability of B. Okay, so that way I will write in the in this format. Probability of A given B is actually is not divided by, should be A given B, that equal to probability of A intersection B divided by probability of B. So actually when we look at this figure, you can see that in B, what is the probability of A? So this is the portion of A in B. Okay, so if we consider only B, so if we consider the section B, so what is the probability of happening A inside B? So that is actually we are finding through conditional probability. Probability of A given B equal to the formula is probability of A intersection B divided by probability of B. So this probability with respect to B is not with respect to S but with respect to B. Okay, the probability of this shaded region with respect to B. So we are considering B as a sample space, or B as a what is that, whole region for this shaded region. Okay, so inside this B, what is the probability of A, or what is the probability of this shaded region in the inside B? Okay, so what that is idea. So for the I will give an example. Suppose you are testing, you are testing, you are checking checking COVID-19. COVID-19 among students in our college. Okay. So there are boys and girls. Okay, girls. The question may be, what is the probability of COVID-19 patients given that, or among the boys. What is the probability that COVID-19 patients among the boys? Okay, there are possibilities. The COVID-19 patient may be boy or a girl. You are checking if you are conducting a what is an antigen test, and suppose all these students are subjected to the test, and we are checking whether suppose we want to find whether probability of COVID-19 patients among the boys is bigger than 0.5 or not. So for that we have to find out this type of probabilities. So that can be obtained through the conditional probability. So probability of A given B can be written as probability of A intersection B divided by probability of B, provided probability of B not equal to 0. It is not 6. It should be not equal to 0. So what is the formula? So this is, you can use this formula, and the condition is probability of B not equal to 0. Okay, not equal to 0. So what are the probabilities, properties of this conditional probability? Suppose you are considering the situation like probability of, suppose we are finding probability of A after occurring event B and probability of A before occurring B. So there are two situations. This is probability of A after occurring B. Okay. And this is probability of before occurring B. So if these probabilities are equal, what can we say about these two probabilities? Or what can we say about these two events A and B? That means after occurring B, probability of A is same as probability of A before occurring B. So if you observe B, we have probability. If without observing B, we have probability. So both that probabilities are equal. So what is the meaning? There is no influence of B on A. Okay, there is no influence of B on A. So with B, probability of A is same as the probability of A without B. Okay, or after observing B, the probability of A is same as the probability of A before occurring B or without occurring B. That means there is no influence of B on A in terms of probability. Okay, so in this case we can say that A and B are independent. Okay, Okay, that means for the event A, we cannot influence in terms of probability. Probability of A before occurring A is same as probability of A after occurring B. Okay, that means A and B are independent. That means B has no influence. B has no influence on A. Okay. So this is one property. Okay. And by definition, here we have definition. So what is the probability of B given B? What is the probability of B given B? So this will be probability of B given B is equal to probability of B intersection B divided by probability of B, that equal to simply 1. Probability of B intersection B is same as probability of B divided by probability of okay. So that equal to 1. So this is the third property. And suppose P of B equal to 0, then we cannot define. So this will be, if P of B is equal to 0, if P of B equal to 0, then this will be infinity, right? This will be infinity, that means not defined. Okay, so these are the three properties of this conditional probability. So the definition of conditional probability is this one. Okay, now we have one law, that is multiplication law of probability. It is very important, and you can see that the multiplication law holds in this conditional probability itself. Okay, so if we rearrange this conditional probability, that means if we put this to left side, okay, so what happens? Probability of probability of B into probability of A given B is equal to probability of A intersection B. So this is the multiplication law. That means probability of A intersection B is equal to probability of A given B into probability of B for two events. So this is the multiplication law for two events. For any two events A and B, probability of A intersection B is equal to probability of A into probability of B given A, or probability of B into probability of A given B, because we can instead of considering B, we can consider A, so that the formula will be like this. We can write like this: probability of B given A, this will be B A by probability of A, probability of A not equal to 0. So when we rearrange this function, you can see that this is nothing but probability of B intersection A equal to probability of B given A into probability of A. Okay, so I think it is clear for you. Probability of B intersection A is equal to probability of B given A. So these two equations, that means this one and this one, are usually called multiplication law for probabilities for if you consider two events. Okay. A simple proof is given here. You can read this proof. Suppose the sample space consists of n sample points, of which n are favorable for A of the occurrence of A, and n B are favorable for the occurrence of B. Okay. Let NAB be the number of occurrences favorable to the compound event A intersection B. So if you look at this figure, so you can say that suppose there are NB observations inside for the occurrence of event B, and suppose there are n a number of observations, number of favorable cases corresponding to the event A, and in this red region, that is shaded region, that is region of the intersection region. Okay, intersection region of A and B. Okay, so let it be NAB. NAB represent the number of favorable case corresponding to the intersection event. Okay, Na is a number of favorable case for the event A. NB is the number of favorable case for the event B. Okay, so so you obtain that numbers, you represented that numbers. So what is the probability of A? Probability of A is nothing but number of favorable cases divided by total number of cases. Okay, so that will be Na by N. Okay, Na by N, number of favorable cases by total number of cases. Right here, probability of A equal to N A by N. Okay, so what will be the, similarly what will be the probability of B, the number of favorable case, probability of B equal to NB divided by number of favorable cases to the event B divided by total number of cases. Okay, so what will be the probability of joint event A intersection B? So that equal to that will be probability of A intersection B, that equal to NAB by N. That means number of favorable case corresponding to the joint event A intersection B divided by total number of favorable cases. Number of favorable cases by total number of cases. So you can see that you have represented probability of A, probability of B, and probability of A intersection B. Now, you know, probability of A given B, that is conditional probability of A given B. That means given that NB observations are occurred, that means corresponding to event B there are NB observations. So suppose given it is given that NB occurrences has been already having corresponding to the event B, then probability of, what will be the probability of A given B? The number of favorable case divided by total number of cases. In the event B, we have NB number of total cases. So out of that NB number of total cases, what will be the number of favorable cases to the corresponding to the joint event AB? So what will be that probability? That will be probability of, so probability of A given B, probability of A given B equal to what will be that probability? I will put in the equation. Yeah, I'm going to take. So what will be that probability? Out of I will take the equation editor. Yeah. So out of NB trials, out of NB favorable cases, the number of joint events, that means A and B, the number of favorable case corresponding joint event AB. So this is the probability of A given B. Okay, given that NB observations has occurred in the corresponding to the event B, then what is the number of favorable case corresponding to joint event AB? That is NAB. So what will be the probability? Number of favorable cases divided by total number of cases. So that is NAB divided by NB. Similarly you can say, what is that? Probability of B given A. So what will be that probability of B given A? That will be equal to NBA divided by NBA divided by NA. Okay, right? NB, number of favorable case corresponding to the joint event BA divided by out of NA number of observations or occurrences corresponding to the event A. So inside A, what is the probability of joint event BA? For example, suppose there are 50 students in your class. Okay, out of which 10 are boys and 40 are girls. Okay, so what is the probability of boy? Probability of boy, usually it will be 10 by 50. Okay, so what is the what will be the probability of A? Sorry, girl. That will be equal to 40 by 50. Okay, and suppose we are checking that the number of students passed in statistics examination. Okay, let it be 48. Two students got failed. Suppose, I expect you are all will success, and for an example you consider 48 students have already been passed. So in a particular statistical examination, any internal examination, maybe or external examination, whatever it is, okay, you can consider an examination in statistics. So 48 out of 50 students, 48 students are passed. So among the 48 students, you will have 9 boys and 39 what is that, uh, girls. Okay, 39 girls. So what is the probability of passing statistics examination what is the probability of passing statistics examination given the information that the students are boys? Suppose A represent the event that passed statistics examination. Okay, and B represent the event that it is a boy. Okay, so you have given that the information that a boy is passed. So what is the probability that you are given that the information that the candidate is boy. So our question is, what is the probability of passing statistics examination? Okay, so A represent the student has passed the statistics examination. So what is the probability of A given B? Probability of A given B, that will be, what is that, number of boys passed statistics examination. So that is given as 9 out of total number of boys, that is 10. So this 9 is actually A intersection B. Okay, number of A intersection B, sorry, number of A intersection B, right? This 10 is actually number of boys. Okay, so this is the idea. So you can represent the conditional probability like this. Probability of A given B is equal to n of AB by NB, and probability of B given A is equal to n of AB divided by n of A. So you can easily write this probability of A intersection B as, now what is actually probability of A intersection B when we consider the original sample space? Probability of A intersection B will be equal to n of number of favorable cases corresponding to AB divided by total number of cases. N of AB divided by total number of cases. Total number of cases. So you can just modify this equation. This is equal to n of AB sorry. റസിൻ സാറിൻ്റെ ആണ്. ആയിക്കോട്ടെ, ഞാൻ ആളെ അറിയിക്കാം. ഓക്കെ 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 ഓക്കെ, അത് ശരി. ഞാനോട് പറയാം. ഓക്കെ ഓക്കെ. സാറേ, ഇപ്പോൾ സാറ് വിളിച്ചിരുന്നു, ജോ കിഴക്കൂടൻ, മാത്തമാറ്റിക്കൽ മെത്തേഡ്സിൻ്റെ ഇൻറ്റേണൽ കയറിയിട്ടില്ല എന്ന് പറഞ്ഞിട്ട്. അപ്പോൾ സാറ് അത് കയറ്റേണ്ടി വരും, കാരണം നാളെ ഇനിയിപ്പോൾ ഇത് വെച്ചിട്ടുണ്ട് പാസ്പോർട്ട്. സാറ് പ്രിൻസിപ്പളിനെ വിളിച്ചിട്ട് അത് കയറ്റാനുള്ള കാര്യങ്ങൾ ചെയ്യണം കേട്ടോ. So this is equal to n of AB divided by n. So that can be written like this. For n of probability of n of AB into n of A. Okay, n of AB divided by n of A into n of A divided by n. So this is actually probability of A given B into probability of A. So this is equal to probability of A intersection B equal to probability of A given B into probability of A. Similarly, you can write like this. So this will be B given A into probability of B. Okay. So this is the equation number 1 and equation number 2. Okay. So that you can represent probability of A intersection B as probability of A into probability of B given A, or probability of B into probability of A given B, right? So this is usually called multiplication theorem for the probability for two events. Okay, multiplication theorem for two events. Okay. So you can write up to this and submit in the Moodle platform. I will share the link in the Moodle platform, and you can study conditional probability and multiplication law. Okay. So I will share this note with you. Okay.